Welcome back to DWeb Decoded, a podcast by Filecoin Foundation that explores the intersection of blockchain and the data economy. I'm your host, Aaron Stanley, and today I'm joined by Alan Ransil. Most of you probably know Alan as the gigabrain behind Filecoin Green, and he's now the CEO of Devonian Systems. So today we're going to be talking about both of these projects and getting the full download. Alan, thanks for being here.
Thanks for having me.
Awesome. So Alan, I'd love for you to take a minute to introduce yourself. You've got a super interesting background at the intersection of sustainability, tech, distributed systems. You've got a PhD from MIT. You spent 5-6 years at Protocol Labs building on Filecoin Green. And then now you've got a new project that we'll be talking about. But we'd love for you to give us some context about your journey and what are some of the common threads?
Yeah, 100%. So I've been, interested in sustainability and building sort of better technical tools for aligning our society and our economy with the natural environment for a long time. I worked on energy storage and power grids at MIT and then in a postdoc right after, and then started working on applying Web3 systems to distributed power grids at Protocol Labs starting in, I think, 2018. So it was a while ago in a collaboration with the MIT Energy Initiative. And Filecoin Green really came out of this idea that when the network launched, it started growing really, really fast at like late 2020, early 2021. And we and a bunch of other people started asking, okay, how much energy is this actually using? How is that energy distributed across the world? What are the emissions implications of this? And really just there's this kind of new frontier around understanding in a decentralized system how to do really solid monitoring of energy use and environmental impact. And we wanted to push that forward with Filecoin itself, sort of by doing these assessments on the network. And if you think about that problem in a centralized system with a company that's doing reporting, according to any of the reporting standards that exist right now, this is sort of the standard way people assess emissions of a product or of a company. It's pretty easy, relatively speaking, because you have the centralized organization that has all the receipts, all the invoices. You sort of understand your operations in a lot of detail, and maybe you don't have the accounting systems implemented yet in order to understand what your emissions are and what your environmental impact are. But you at least have an accounting system that you can go to use as the basis for that. And suddenly, in a decentralized system, you really have to strip that back and start from the point of view of, okay, what is the protocol? How is this protocol being designed? What can we tell about the activity in the real world that people are doing just based on these messages, right? And so I had been working on decentralized power grids for a while and had done a lot of work with some of the teams that were building the proofs for Filecoin, these ZK proofs that are really the core of the Filecoin protocol itself. And in 2021, we really started sort of applying that to understanding Filecoin's energy use, Filecoin's emissions. And we pushed that along quite a bit for several years within Protocol Labs, and we've spun out with nucleation into a couple different teams. And happy to get more into what we've been doing since then.
Yeah, and I love the Filecoin Green project because it's really, at least from my vantage point, it's really probably the most interesting attempt to really bake kind of sustainability and specifically verifiability of carbon emissions into a Web3 native system that I've seen. There's a lot of, we've seen a lot of these kind of refi projects and things kind of, ESG focused blockchain projects kind of come and go, but it doesn't seem like, a lot of these never really addressed this at the protocol level, like what you're talking about. And we had this era of kind of the Bitcoin energy FUD, right? Which I guess we haven't really heard so much about that since BlackRock came out with a Bitcoin ETF. But people would say Bitcoin uses more energy than the country of Denmark or whatever, and that's bad, right? It's we don't really know exactly how where all that energy is actually coming from. How much of this is renewable? How much of this is coming from coal or other sources? There's not really a way to track that inherently. You're just kind of relying on people reporting if they choose to report at all, which I'm assuming most of these miners probably wouldn't do that.
Yep.
But the idea with Filecoin is we're just going to try to bake this directly into the protocol. And so each individual node, we can kind of address what is their energy mix, basically, how much renewable, how much how much of whatever other source. Anyway, I mean, I would just love for you to maybe kind of riff a bit more on just that idea of just baking that into the protocol itself, and having that, like, why it's important to have that like degree of verifiability like at that level, and not just relying on like kind of voluntary reporting, basically.
Yeah, 100%. And if you take Filecoin and think about it sort of in terms of first principles, it's this set of zero knowledge proofs that let you prove that you have a certain amount of hard drive space committed to the network. And that could be hard drive space, or it could be live data on the network, right? And Filecoin it's a series of messages, right? Any blockchain, right? It's a series of messages that are validated over time. And so when you look at Filecoin from a very sort of first principles point of view, what people are doing to participate in the network are generating these proofs and then validating those proofs over time, right? So you commit capacity to the network. You do this process called sealing that takes GPUs, it takes CPUs, it takes solid state drives, and you can tell something about like what's going on in the real world when people participate in this network just based on the cryptography behind those sealing proofs. And so that was the first thing we did, is we talked to a lot of storage providers and we looked at benchmarks, we interviewed SPs, and we tried to get to a place where we could say, okay, for every sector, for every X number of gigabytes that you've contributed to Filecoin, what do we think on average people are using energy-wise to do that, and what are bounds on that, right? And so that's one of the components that goes into this. Then the next component is you have to actually store that data over time, right? Which means you need hard drives. Those hard drives are spinning up at least once a day in order to generate these post proofs to prove that you still have that capacity on the network. And then again, so we looked at surveys, we looked at data sheets from different hard drives people were using. We took data from a bunch of different sources, looked at benchmarks again, and again said, okay, what's the estimate, and what are the upper and lower bounds on the amount of energy that people might be using in the real world to just generate those proofs? And then what we looked at, the third kind of piece of this, is the energy efficiency of data centers. Filecoin is unusual compared to a blockchain like Bitcoin because you don't generally use ASICs for Filecoin, right? A Filecoin data center actually looks really similar to a data center that you'd use in like Web2 worlds because, and there's a reason for that, right? Filecoin, the entire point of Filecoin is to provide utility as sort of an externality to the crypto econ of the network itself, right? That we're storing data for people and getting compensated for that data. So it kind of makes sense that your data center wouldn't look like some like kind of different new thing, right? It would just look like a data center that you use to store data for people and allow them to retrieve that data. So so what that meant was that we could rely on a lot of literature from sort of Web 2 data center world on the efficiencies of data centers and things like cooling and things like thermalization, and look at what's called the power usage effectiveness. So that's like how much of the energy that you're using is actually going into running the GPUs and CPUs and hard drives versus how much is going into things like cooling and other sources of overhead. So those are the three components, right? Is storage, or sealing, storage, and power usage effectiveness, or like the efficiency. And if you go to filecoin.energy, you can see our model, and we've updated this recently. We have a new model that we updated in the past couple of months for our estimate and our upper and lower bounds for energy use for the network as a whole and every individual storage provider, right? So using the messages that they've submitted to the chain and trying to get an idea from the IP addresses that they use to submit those messages as to where in the world those nodes are or what the geographic distribution of sort of energy use is. You can look all that up on filecoin.energy.
Maybe walk us through. I know you guys have put a lot of energy into, not just like collecting and trying to aggregate and build a system to, sort of collect this information, but also like display it and make it, kind of easy to access as well. And I know you've done some updates on filecoin.energy recently. Maybe kind of walk us through what is it that I can see on this site, and like what is it that I can access, or what can I verify?
Yeah. So one of the things that you can look at is the geographic distribution of energy use across the world that the network as a whole is using. And then if you click on one of those individual countries, you can look at the estimated energy use of Filecoin SPs in that country. And then what you can do is you can look at, for any individual SP, you can look at the amount of energy we think they're using for sealing, the amount of energy we think they're using for storage, and then the emissions associated with that SP. And then I think one of the big upgrades that we've done recently has to do with not just what are the fundamentals of in a distributed system, how do you know how much energy people are using, but also some of the complexities of actually measuring the emissions from those operations and like trying to translate that into a number that's actually actionable. So recently, we just released something that we call a green score, which gives you this number from 0% to 100% of how sustainable we think that storage provider is. And it's normalized relative to other SPs in the network. So what people really wanted when we talk to people about, how are you going to implement sort of more sustainability in your Filecoin use, right? They don't really want like an energy number. They don't really want an emissions number. They just want like some performance metric that they can use to determine like, I'm going to store with this SP rather than this SP because we think they're more sustainable. And there's a ton of complexity, right, into just like measuring all of this stuff. There's complexities that we just went into kind of around how you do this in a distributed system, and then there's complexities in what it means to be responsible for carbon emissions when you're plugged into a power grid, right? So the kind of traditional way of measuring emissions is the total emissions from the grid are like the whole pie, right? And then what I'm responsible for is my fraction of the total energy use within that grid, right? So I'm responsible for this like slice of the pie. That's one way of measuring it. That's a great way of measuring emissions, but it leaves out a lot of the complexities of like what actually happens when you add load to the grid, right? What actually happens when you add load to the power grid is that the base generation actually stays constant, right? So there's all this stuff like nuclear power plants or like coal power plants, by and large, are not ramping up and down a lot when you like flip on a light switch or when you interconnect a new data center to the grid. But all of this other stuff is turning on and off. So like natural gas turbines are often are meant to spin up really fast and spin down really fast. And clearly like solar and wind are doing their thing. Batteries can react really, really quickly to changing grid conditions. So a different way of measuring your emissions on a power grid is looking at the consequences of adding that load to the grid. So rather than saying, this is my slice of the pie, what you say is, if I didn't have this load, what would the change in emissions be? So that's like your sort of marginal contribution to emissions from that power grid. That's a totally different way of measuring emissions. You focus on a different set of metrics for doing that. And so we've taken both of those and turned those into what we call an emissions score. This is the like slice of the pie methodology. And then a location score, which is this sort of marginal emissions contribution. If you turn on a load at this point in the power grid, what is its marginal effect on the emissions of that grid? Then a third sort of level of complexity, which we touched on a little bit, is just how good is your information, right? And are we getting this information just from publicly available sources on the network? Or has this SP gone through some extra reporting and worked with a company like Nova Energy, which spun out of Filecoin Green? They're doing excellent work on auditing different storage providers and folks in other Web3 ecosystems too, in order to assess their energy use, verify that they actually are where they say they are. If they're doing things like they're building solar on the roof, some great SPs are doing that, or using solar from adjacent facilities, accounting for that. Just like the level of quality of your information is a huge factor in determining, how confident are we in telling someone that their DApp should use this SP versus this SP if they care about sustainability, right? So we take those three different scores, the emission score, the location score, and the confidence score. Those are each a number from 0 to 100%. And we average those to get a green score. And that's this like final number that we say is like, this is your metric that you should use to determine if you want your dApp to be as sustainable as possible, to determine which SP you should go with. So taking, kind of all that, like these kind of separate worlds of complexity and baking that down into one sort of easily digestible number.
Yeah. Yeah, that's a lot. Yeah. It's like 3 hyper complex things combined into one sort of ultra complex thing that's sort of you're trying to bake it down into a digestible number that like, an average person I just want a number from 1 to 100. Like,
exactly. Yeah.
Like what is this relative? What is option A relative to option B? Like,
you don't want your API call result to be this like massive data structure with like all of the detail of that. Like ultimately, you just want a number to say like, okay, I'm going to use this one, not this one.
Yeah, exactly. Yep. And I mean, is it possible to really? I feel like one of the challenges here would be, in a lot of ways, like the SPs are going to be dependent on the mix of the whatever local grid that they're on, right? Yep. So if the local grid is take a place like, Quebec, Canada, where it's like 99% hydroelectric, right? Or if you're maybe in somewhere other place where it's like 100% coal, right? Like the SP doesn't really, or, it maybe those examples would be kind of easy to verify because it's like one extreme or the other. But maybe in a place where it's, we don't really know, is it like 30% renewables versus 70% carbon, or is it like 50-50? Maybe some jurisdictions are going to be, that data is going to be more available than in other jurisdictions or in geographies. Like, how do you kind of weigh that in? And like, I mean, I guess the goal isn't necessarily like, punish a storage provider for not having like 100% renewable energy, but like, how do you kind of weigh some of these things that are like, to some extent, like out of the storage provider's control over like what the mix of the local energy grid is?
Yeah. So that's what goes into the sort of nuts and bolts under the hood of these 2 different carbon emission scores. So the emission score and the location score. And those numbers that you're talking about. So if you are at this geographical position on this power grid, what are your emissions and what is your marginal impact on the grid? Those numbers are provided by this group called Watt Time, which is a nonprofit in Oakland, California, that puts a ton of effort into trying to solve exactly those types of problems. And so what we do is we use their API and we calculate these emissions numbers, right, from storage providers on a grid in this country, in this geographical location, and we convert that to a carbon emissions number. And then the extra complexity of how does this sort of stack relative to other SPs then goes into the normalization of that score. So like ultimately the emission score and the location score are 0 to 100, where the underlying carbon intensity of electricity in that power grid is baked into that score.
Got it. Okay, that makes sense. So there's actually like a third-party group that is kind of collecting all this information that you guys are sort of plugging into. So you don't necessarily have to go around trying to find all this information yourself. It's already being collated and collected.
Yeah, and there's groups called like Watt Time and Tomorrow. You can look at these really great maps of the power intensity of grids in real time all over the world that are pretty cool to browse if you're into that kind of thing.
Interesting. And I want to talk about Devonian, your new project, but I have a couple other questions here before we get to that. Do you see? I mean, Filecoin's like a pretty unique project. Obviously for a variety of reasons. But like, do you see what you've done with Filecoin Green being kind of, is this something you can kind of copy and paste to other like Web3 protocols that involve, could something like this be used, for the Bitcoin network, for example, or another kind of proof of work network that uses a decent amount of energy? Or is this really something that's really more kind of hyper localized to Filecoin at the moment?
Yeah, I think the methodology around the green score, I think, is a really solid way of taking a lot of these different complexities and boiling them down into a single number that's actionable, but that reflects sort of the trade-offs between those different complexities. So I think that has a lot of applications across different projects. I think that the details of how you apply a metric like that to a given project might vary. So with Bitcoin, right, individual Bitcoins are fungible more or less, right? Whereas with Filecoin, when you store data on the Filecoin network, that data storage is tied to an individual storage provider or a given miner ID. And your data storage is not fungible with other people's data storage. So the way we applied green scores to Filecoin itself is really based on helping people get the information that they need to make decisions around sustainability when they are actually like using the network and getting utility from that network. I think that different projects have worked on green Bitcoin and tried to deliver that information in different ways, right? But I think like when you're trying to apply these sort of incentives to a network, you really have to like start with a model of, all right, what are the decisions that people are making as they interact with that network, where we want to give them the information that they need to make like decision A instead of decision B, right? And in Filecoin, that is, I want to store data with this SP rather than this SP. But different networks may, your mileage may vary, right? And you have to kind of be creative in what types of decisions that you're trying to incentivize.
Yeah, well, with Bitcoin, it's a bit different because you have, say if I'm just transacting on the Bitcoin network, like I'm not necessarily choosing like which node I want to like broadcast a transaction to or what, or like there's not. It's just there's not that level of decision. It's just I just want to send the transaction. Like I'm not sending it to one. I'm not choosing one miner over another miner or anything like that. That's totally abstracted away essentially. Whereas with Filecoin, that becomes a bit more of a that's an area where people can make a decision if they care enough about if they want if that's a priority for them.
Right.
And then maybe one more question here before we get to Devonian, but I know that you and Juan Bennett have the founder of Filecoin IPFS have been really talking about some of these questions for like 15 years now. This whole idea of sustainability, decentralized systems, even back before Bitcoin was even a thing, before IPFS was a thing, before Filecoin was a thing, and I would really be interested in your perspective on just what has it been like, kind of seeing like. What has it been like kind of being ahead of the curve on this and then seeing all these issues kind of play out in real time and being able to kind of construct solutions along the way that address some of these problems and are kind of relevant to the tech as it's advancing or as it's developing. So anyway, I would love for you to kind of riff on that because I just this is super interesting. Just that, I assume like you and Juan go back to like, college roommates or whatever, talking about this stuff. And like now it's all of a sudden it's a real thing.
Yeah, 2006. It's been a while. Yeah, I think that a lot of the conversations that we had early on were really on applying sort of epistemology and ideas about the growth of knowledge to new technical systems. And I think that is one of the places that IPFS has always being intended to go, right? And you're seeing some of this in DeSci, right? And taking a lot of these sort of Web3 tools and applying them to better knowledge management. I think that the incentive mechanisms for funding knowledge, funding the growth of knowledge, right? Funding like new research projects into all sorts of different things, right? Like DeSci is this like kind of burgeoning, like really exciting area where people are setting up DAOs to do research in all sorts of like really specialized areas. Like I think that is a little more explored than some of the really fundamental stuff that we were talking about earlier on, which is maybe a good bridge into Devonian, which is that when you were trying to build better tools for knowledge management, the way that our models work now, so our models for applying knowledge to, say, new engineering systems, and then also sharing those like scientific models that we've built, everything is just like, it's still really disconnected, right? So you can't easily, for example, take a scientific paper and just in one click or a few clicks, reproduce the analysis that went into a figure or a table in that paper, right? And this is where sort of a lot of the thinking started, is what would be sort of better technical architectures for allowing people to do that. Like what would a better system be for allowing you to take this like constellation of scientific models that we have, scientific and engineering models that we have, that right now are their own sort of like individual points in this sky of human knowledge. And rather than make them individual points, make them sort of more of an interconnected whole. And one of the most exciting things about IPFS and content addressing, right? And one of the things that Juan was like really thinking about when he sort of started building this, is that content addresses give you a universal coordinate system for data, right? So for a long time, people have used hashes to verify that data exists within the context of a single data structure, right? So I'm thinking about like a Merkle tree, where the point of a Merkle tree is that you have this, this tree of hashes that allows you to construct inclusion proofs very easily. So you can say if you have the root and you have like some individual node on this tree, you can very efficiently build an inclusion proof showing that like, yeah, this little chunk of data is the data that you are looking for in the context of this larger tree. So like, that's great. So that's something people have done for a long time. But if you want to interconnect all of human knowledge, like firstly, you have to be able to verify one little scrap of data in the context of all data that people have generated sort of over the course of history. And the core realization of a lot of Web3 tooling, and IPFS especially, is that hashes are massively overpowered for proving or verifying data in the context of a single data structure, right? They actually give you the power to verify a little scrap of data or a large piece of data in the context of not just this one Merkle tree, but like all of the Merkle trees, right? Or all of the sort of compendium of human knowledge that people have generated. And that's where I'm really hoping that we can sort of push a lot of our work, is not just like the incentives are interesting, right? But this like fundamental piece of like, how do you take these disparate islands of knowledge that people have built and interconnect them? And this gets really interesting when you start adding AI that can then sort of use this universal coordinate system for human knowledge to then operate on top of all of these individual scientific models, right? Like maybe that gets you somewhere really interesting. And that's at Devonian, the way that we're approaching this is through auditing and compliance reporting, and especially for carbon projects, sort of applying some of this thinking to how people take data sets for individual carbon projects or individual projects that they're working on, use Web3 native tooling to operate on top of that data, and then build reports that have LLMs involved, right? They have AI generated sort of human readable outputs, but that sits on top of this verifiable layer that sort of gives you the ability to audit these reports and these projects more effectively. So that's sort of where we're going with Devonian, is thinking about this from a really sort of fundamental first principles way of where do these Web3 tools give us the ability to interconnect claims that we're making, and then use that for really practical outputs that actually get carbon projects off the ground.
That's super interesting. I know you guys have done some work with like Gain Forest and some others as kind of maybe like a prototype example of how this type of system can be used. But maybe maybe talk a bit about just like what are some of the applications that you see here that you've been kind of piloting perhaps, and what have some of the results been in the early days here?
Yeah, I'll go really narrow, and then I'll go broad, and then maybe a bit broader. So I think narrowly, what we're looking at is that there are many carbon projects. There are many companies and individuals throughout the world who would love to get paid for, say, growing trees on their land, or restoring degraded land, or protecting forests, or growing mangrove trees, like all sorts of nature positive work that people would love to get compensated for. But there's all sorts of reasons where today they can't. And a lot of that has to do with the fact that carbon registries right now are not set up to allow this sort of flourishing of small projects all across the world. They're really set up with a ton of barriers to actually getting those projects registered. So typically, if I want to start a nature positive project, I have to raise $500,000, $1 million, a couple $1 million to just go through the process of registering that project on a carbon registry and starting to issue credits. And typically, my starting point is I have an idea for a project, and I work with some external consultant to do a feasibility study that might take 6 months or 8 months and cost me tens of thousands of dollars. And I didn't even know going into that if they're going to give me a thumbs up to keep on going on with this project, or if they're going to get to the end of that and say like, nope, you can't do this. This isn't going to work for whatever that reason is, right? And that's a crazy barrier to put up when someone is just starting out on a project, right? And so what we're doing with Devonian is we are letting people set up a project and a data hub associated with that project on our Churdy platform, churdy.io. And what they can do is then they and people affiliated with the project can upload data that is all content addressed, that's stored in IPFS and Filecoin, and they can start to build the data systems associated with that project up with a really, really low barrier to entry. And then what you end up with is this data hub where you have all this content addressed, all this version data that lets you start to run those feasibility studies automatically. And so we have these report templates and we have AI models that operate on top of the data in this hub. And what you do is you start out by, maybe depending on the type of project you're building, maybe you start out with some lab soil samples to see, is this soil in the right pH range for me to start an enhanced rock weathering project where I'm going to use basalt, this like rock that's mined that pulls carbon out of the air when you crush it into small particles and spread it on a cropland on a field, and it also improves your crop yield when you do that. So maybe my starting point is I just collect some soil samples and I go to a lab and I upload those soil samples to Churdy, and we do this sort of initial really low barrier to entry automated report looking at the results of those soil samples for your project. And that starts to give you a data point, right? That's not like I spend 8 months and I pay $50,000 to a consultant and maybe they say, they give me a thumbs up or thumbs down. That's like, can I just kind of like incrementally build the case for this project using verifiable data and Web3 tools along the way, so that when I get farther along in that process and I'm trying to get more investors or I'm selling credits, I have this whole auditable trail that relies on Web3 tooling to allow me to do that. And so we're taking, bringing this back to that sort of larger vision for knowledge management, right? The individual data sets are content addressed. So they take advantage of this sort of IPFS hash-based universal coordinate system for human knowledge, right? They are then fed into auditable pipelines that themselves are content addressed, right? So we use essentially code NFTs to do operations on data from this carbon project that then spit out these useful data sets that are used in reporting. That becomes the basis for figures or tables in your report. The report itself is written by an LLM, or like the text is, but everything maps back to this verifiable data layer that's underneath that. And really trying to use that to like identify what are the barriers to people doing this type of work and reduce those barriers as much as possible.
Oh, I love that. So the objective is really just to get to like you said, like break down these barriers, make it easier for people to embark on these projects, and like try to remove some of these like perhaps like disincentives of having to pay $50,000 for a feasibility study, like you're mentioning, to do these types of things, which is obviously not something that most people are going to like most people probably don't have the money to be able to do that, right? Like to
Yep.
be able to just front that for a project that may or may not become something. So, so really like a lot of the, perhaps like the smaller investors or like smaller entities that might want to embark on a project like this are just sort of immediately crowded out and like, just there's no incentive for them to participate in this, irrespective of how much they might like want to, right?
Yeah, exactly. And that like initial feasibility study is like maybe 50 to 80K. And that's the first step of a series of steps that each cost tens of thousands of dollars or 100K and take months. And at any of those steps, your project could just be over.
Yeah, right.
Done it, right? And so we're sort of using a lot of this Web3 tooling to give people better control over and sort of better visibility into like where their project is going to be able to checkpoint that along the way.
No, I love that. Well, Alan, we're at time here, but I really appreciate you coming on the show. Would love to get any quick final thoughts from you. Where can folks go to find you and learn more about what you're building? And we'll have to have you back on again in a few months to get a status update, because this is super interesting what you're working on, and would love to see how this is all progressing. But any final thoughts from you, and then how can folks find you?
Yeah, 100%. So if you're interested in the energy dashboard stuff, that's filecoin.energy. That's where you can look up details on energy use for the network as a whole and for individual storage providers. If you are interested in the really great work that Nova is doing, you can go to Nova, I think it's novaenergy.ai. And they're doing really great work auditing different storage providers and also nodes in other Web3 systems, and working with them to sort of publish that data and provide sort of visibility into the environmental impacts. If you're interested in what I was talking about with Devonian, you can go to cherty.io. Cherty is the tool, CHERTY.io, the tool that we're building for verifiable reporting. And if you are coming to ETHSF or you are in the area for ETHSF already, please check out the Funding the Commons and Earth Commons conference that's going to be going on at the Internet Archive on Saturday and Sunday.
Awesome. Cool. Well, thanks everyone for watching, and thanks again, Alan, for your time, and thanks everyone else. We'll see you on the next episode of DWeb Decoded.
Thanks so much.